Good evening, all. You're welcome to online tutorials with Fametante the schoolboy. Today, we'll take a look at mathematics. And the topic for today is number basis. With this source script are the basis of each of these numbers. By rule, if you have a number such that the base, let's assume we have a number such that the base is b, all the digits in that number must be less than what? B. None of the digits should be equal to or greater than the what? The base. None of the digits should be equal to or greater than the base. B represents the base. So all the digits in that number must be less than the what? The base. So that's why you see things like this. 216 to base 7. 7 is the highest digit here is 6 and it's less than 7. The highest digit here is 6 and it's less than 7. The highest digit here is 4 and it's less than 5. So please, you cannot have a number like this, 216 to base 6 or 216 to base 5. It's wrong. It's wrong. Maybe by in operation, and if by operation, when operating in a particular base and you arrive at an answer like this, you keep dividing. Don't worry, by the time we enter operations in number basis, I will explain that more. You keep dividing until you get what is less than this what? Base. Okay, so all right, so now this number basis also shows something. This number basis, they show how the counting in that particular base goes. If you have a number in, we have base 8, 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8 are permissible. We have base 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 is not inclusive. 1, 2, 3, 4, 5, 6, 7, 8, 9 are permissible. Then base 10, the commonest one we use around the world is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 digits that are permissible for a number in base 10. There are 10 digits in number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you watch our counting, normal natural number will count is built using what? Base 10. Using what? Base 10. Is built in base 10. That the system we use in our normal counting number is in base 10. That's why every number you have from 1 to 1 million must have any of these digits. Is built upon any of these digits. You now start, for you to now get the one you're looking for, you now start placing them in a particular position. This is digits. You know, every number, as you see here, has what is called face value and place value. Here, look at this one. Here is 0. Yes, that's the face value. It's 1. It's 2. But that's how you place these 2. It will become 200. It will become 20. It will become 2,000. It will more than the normal 2 you are looking at. That's where place value now comes in. So, because of the place value, because for you to build a numerates in a particular number base or counting system, you need to position these digits, whether you are operating in base 4, operating in base 5, operating in base 6, you place them in a position that will give them value with respect to what you want to achieve. When you are doing that, you are giving them a place value. So their place value is also important in enumeration. So based on this now, we'll go to what is called place value, because the place value is important in what? Number system or number basis. If you don't understand place value, you'll not be able to carry out any operation in number basis. So this will take us to place value. What is the place value of a number or a digit, as case may be? Place value of a digit is the value of that digit in a number in relation to its what? Position. Place value of a digit is the value of the digit in a number in relation to its position in that number. Let me use a number as an example now. Let's assume we have 200. No, let's assume we have 222. Look at this three. This is 222, right? Working in base 10. This is 222. If you look at the face value of this number, there are two. You think that they are the same thing. No, this first 2 here and this 2 here, this 2 here, and are not the same thing. They don't have the same value. This 2 here is in 100. This 2 here is in units. It's just unit, just 2. You can say 2 times 1, just 2. Just ordinary 2, which can be taken as 2 times what? 1. This 2 here is not ordinary 2. It has. Remember, we are working in decimal base 10. So it moves a bit. It shifts by 10 units from this first one. So whatever here you are putting here, the value of this is value of this times 10. So the value of this one now is what? 2 times what? 10. The value of this 2 here and now is 2 times 10 because it's 10 times more than this one. That is the place value. Now, this one here is not the same thing with all these ones. It's 10 times more than the value of this, and 10 times 10 times more than the value of this. So this 2 here is 10 times 10 times 10. So this 2 here is unit. If you know your law of indices said that any number raised to power 0 is 1. So because we are working in base 10, this can become 2 times 10 raised to power what? 0. And this can become what? 2 times 10 raised to power what? 1. While this can become what? 2 times 10 raised to power what? 2. As you can see now, this one is in 110 units. I will say that these 3 digits, they don't have the same what? Value. The same place value. So if you are working in any of these bases, let's assume you are working in base 2, this 10 will now be replaced by 2. This 10 will now be replaced by 2. I use 10 because I'm working in base 10. The same thing if you're working in base 3, everything here will be replaced by 3. If you're working in base 6, this you now have 2 times 6 raised to power 2. So this is what we mean by what? The 6 is senary, 7 is septenary, 8 is octal, 9 is nonary or nonal, 10 is, I have said it here, denary, decimal, 11 is undecimal, undecimary, 12 is duodecimal or dozenal, duodecimal or dozenal, dozenal, duodecimal or dozenal, dozenal or duodecimal. That is for 12. Undecimal is 11. 10 decimal or denary, 9 nonary or nonal, 8 octal, 7 septenary, 6 senary, sorry, 5. All right, please, let's continue. Okay, so this is just we stop at 12. These are the number bases available. There is more than that. We also have up to 16 hexadecimal, all those things, 16 hexadecimal and what have. There are many of them, but we'll stop here. So we don't spend the whole today talking about listing the number bases. Okay, with this now, we'll go over to the operations. Okay, conversions. We have introduced number bases. We'll go over to what? Conversions. How you can convert move from the common base, which is base 10, to other bases, and how you can move from other bases to what? Base 10. Remember I said that we are talking about, we have these number bases as whole numbers, or as integers or non-integers, or let me use whole number as, let me use integers and non-integers, okay? Any of them. But we want to, in a layman understanding of whole number, we want to use, whatever we are going to do now is based on the whole numbers alone. When we are done with the operation in whole numbers, we go over to what? Fractions. Am I communicating? Fractions. Okay. So, excuse me. All right, so let's go there. So whatever we are doing now is respect to whole numbers. We have not started. When we are done with that, we enter fraction. All the operations, both the operations, addition, subtraction, divisions, we see it in the whole number. We also do that in fractions. So now we want to go over to conversion, how to convert from base 10 to other bases, and from other bases to what? To base 10. Okay. Okay, we'll look at our reference book for today is New General Mathematics. New General Mathematics by M.F. McRae et al. Both the book 3 for JSS 3 and SS1 and SS1. So these, most of the examples we are going to solve today will come from these two textbooks. Okay, so let's pick some questions, and we'll take it up from there. Okay. Okay. This question says from book 3, for JSS book 3, it says convert the following base 10 numbers to base 8. Convert the following base 10 Okay, the first one is 15, 27, 128. 15, 27, 128. 569, 1239. 569, 1239. Then F says 5046. This is taken from this book 3, exercise 1B, page 9. That's where I got this example. So let's solve it and see what we can make out of it. Okay, we want to move this from base 10 to base 8. So we are moving from denary, whole number, to octal. These things are whole number, no fraction here yet. So let's move this from base 10 to base 8. Now, if you want to move from base 10 to other bases, it's simple. Just keep dividing the number. If you want to move any number from base 10 to a particular base, use the base you want to move to keep dividing the number. You keep dividing the number until you get 0. And each division you carry out, you keep the remainder by the side. Even if the remainder is 0, still keep it by the side. And you keep dividing the number until you get 0, nothing else to divide. Then you now read that you writing out the remainder by the right hand side. When you are done, you read the remainder upwards. You read the remainder upwards. So that's how to do what? Move numbers from base 10 to other bases. So we have example here for base 8. So let's move these numbers to base 8. Okay, let's start with 15. The first one, A. Solution. Sorry, I will be checking from time to time, checking my listing, so that I'll be sure that we've not been disconnected. Network is not that strong here. All right, so please permit me to be doing that, please. I need to be checking from time to time, maybe every 10 minutes or so, so that I will not be cut off. All right, so now let's solve the A part, 15. So remember what I said, we keep dividing by this what? By this what? The base you want to move into. You want to move it to base 8. So you divide by 8. But just let me see if this thing can work here. Excuse me. Okay, so we have A. So we keep dividing 15. 8. If 8 divides 15, 8 divides 15, we have how many 8 inside 15? We have only 1 8. So we have 8 as a whole number. 1 8 as a whole number. So we have 1. The remainder is what? 7. So 1 times 8 is 8 plus the remainder 7 to give you 15. So we are correct. Remember, we keep dividing until this thing turns to 0. You divide again by 8. If you divide by 8, 8 divide 1 is what? 0. Remember what? 1. So if you go to this level, you do what? You read upwards. So 15 in base 10 will give you what? 1 7 in base what? 8. 1 7 in base 8. So that's the answer to this question. So for 27, you will do the same thing. For 27, you divide by 8 again. 8 divide 27. How many 8s can we find inside 27? How many 8s can we find inside 27? We have 8 times 2, 6, 8 times 6, 24. So we have 3 complete 8s. So we have 3. 3 times 8 is 24. 27 minus 24, the remainder is 3. So 3 remainder what? 3. You divide again. 8 divide 3 will give you 0 because 3 is less than 8. 0. Remainder what? Bring out this remainder. 3. 3. So you read upwards. 3, 3. So 27 to base 10 will give you what? 3, 3 to base what? 8. Then the next one, C. C part says we should move 128. We'll keep dividing again. 8 divide 128. Let's go. 8 divide 12. 8 divide 12 is 1. We have 1 inside 8, 12. 1, 8 inside 12. So 8 divide 12, we have 1. The remainder will be 4. 1 remainder 4. So what are you going to do with that 4? Remember this one, 128 is in base 10. So you multiply that 4 by the base you are working on. If you multiply 4 by 10, 4 times 10 is 40. You add the next digit. It becomes 48. Then you keep dividing. 48 divided by 8 will give us what? 48 divided by 8 will give us what? How many 8s can we find in 48? How many 8s can we find in 48? 48. 40 times 5 alone. 8 times 5 is 40. So 48 divided by 8 to give you 6. There's no remainder. So 6 remainder what? 0. 6 remainder what? 0. You must put that 0. Then you keep dividing. 8 divided 16 is what? 2. 2. Remainder what? 0. 8 divide 2. Here will turn to 0. You bring out this remainder. 0 remainder 2. So 128 in base 10 will give you what? 200 in base what? 8. It will give you 200 in base 8. So if we do the same thing for 5, 5, 6, 9, we have something like this. That's number D. We keep dividing. 5, 6, 9. 8 divide 56. How many 8s can we find in 56? How many 8s can we find in 56? How many 8s? 8 times 8 is 64. So remove 8 from 64. It will give you what? 56. So 8 times 7 is 56. So here should be what? 7. Here should be what? 7. There's no remainder. If you multiply, the remainder is 0. If you multiply that 0 by 10, it will give you 0. Add it to 9, it will give you 9. So 8 divide 9 is 1. Remainder 1. So you have 1, remainder 1. 1, remainder 1. So 8 can go again. 8 divides 71. 8 divides 71. 8 times 8 is 64. If you add another 8, what will it give you? It will give you 72. So it's not even up to, it's more than 71. So 8 divide 71, you have 8. 8 remainder, you have 8. Because 8 times 8 is 64. So 71 minus 64 will give you 7. So 8 remainder 7. Then 8 can go again. 8 divide 8, 1. Remainder 0. Then 8 can go again. 8 divide 1, 0. Remainder 1. You read upwards. So if you read upwards, you have something like this. That 5, 6, 9 to base 569 to base 10 will give you 1071 to base 8. 1071 to base 8. Okay. Okay. All right. So now let's go to the next one, which is E. E says 1239. So divide again. 1239. Let's go. A divide 12 is 1 remainder 4. Yes, because there are 1 8 inside 12. Remainder is 4. 1 remainder 4. That remainder you multiply by 10, which is the base you are working on. Multiply by 10, it will give us what? 4 times 10 is 40. Plus the next number, 3, it becomes 43. You keep dividing. 43 divided by 8 is 5, because there are 5 8 inside 40. Remainder will be 3. So 14 divided by 8 is 5. 5 remainder 3. That remainder I gave you multiply by the base you are working on. We are working on base 10. So 3 times 10 is 40. 3 times 10 is 30. 30 plus 9 is 39. You keep dividing. 39 divided by 8. I didn't mean it's 40. I would have said 5, but it's 1 less than 40. So 39 divided by 8. We have 7. No, sorry. We have 4. We have 4 as a whole number there, because 40 divided by 8 is 5. So we have 4 8 as a whole number. So we have 4. 4. What is remaining there? What will remain there is 4 times 8 is 32. So 39 minus 32 is 7. So remainder 7. So let's go again. 8. 8 divide 1 15. We have 1. We have only 1 8 in 15. 1 remainder 7. So that 7 that's remaining, you multiply it by the base of this number, which is 10. 7 times 10 is 70. Plus the next digit, 74. 8 divides 74. We have already established that 8 times 8 into 9. 8 times 8 is 64. 8 times 9 is 72. So remember, we want to divide 74, right? 74 divided by 8. So we have 9. Remainder 2. You continue dividing by 8 again. 8 divided 19. There are 2 8s inside 19. 8 divided 19 is 2. 2 times 8 is 16. 19 minus 16. The remainder is what? 3. Remainder 3. This one is 16. Okay. 8 will go again. 8 divided 2 is 0. 0 remainder what? 2. So you read upwards. So 1239 to base 10 is equal to 2327 to base 8. 2327 to base 8. Please, if you have any question, feel free to ask. If you have any question, if you are confused in any area, please feel free. You can drop your question on the WhatsApp line on the board, this WhatsApp line. You can drop it on this WhatsApp line. This WhatsApp line is to collect questions whenever we are online. 070, okay. This is Nigerian number. +234 7012 945891. Okay, just drop your questions here, or you can drop it there on WhatsApp on the excuse me. Please just take a look at this. See if there's any place you're confused, please call my attention right away. Okay. We want to go to the last question on the board. Last question on the board. That's what we want to go into now. Tony, you're welcome. Yusuf Yaro, you're welcome. Wireless Moose, you're welcome. Victory, Jojo, you're welcome. Jojo, you're welcome. I'm trying to see the possibility of seeing people here without moving over to that side. That's what I've been trying to do. Okay. So, all right. So, no time to waste. Let's solve the last question. I think let me clean here. The last question says I should convert 5046, move it to base. That is in base 10. We should move it to base 8. All right, let's go. We continue dividing. This is F. So 8 divide 5046. All right, let's go. All right, 8 divide 50. How many 8s can we find as a whole number? Okay, good. Is opening. Okay, let's go. 8 divide 50. How many 8 can we find as a whole number in 50? 8 times 5 is 40. 8 times is 48. So we can have 6 8s. So 6, remember, is 2 because 50 minus 48 is 2. So that 2, remember this is in base 10. You multiply that 2 by the base you are working on. So 2 times 10 is 20 plus the next digit, it becomes 24. So 24 divided by 8 will give us what? 3. Remember 0. So here is what? 3. 3 remainder 0. That's remainder 0. You multiply by the base you are working on again. 0 times 10 is 0. Plus the next digit. 0 plus 6 is what? 6. So 6 divided by 8. 6 divided by 8 will give us 0. Remember what? 6. 6 divided by 8 will give us 0. Remember what? 6. So 5,406 will give us, divided by 8 is 630, remainder 6. You can check it up and see whether it's true or not. So let's continue. 8 will go again. 630, this is 63 divided by 8. What will it give us? 63 divided by 8 will give us what? How many 8 can we find in 63? In 64 alone, we have 8 8s. 8 8s. But with this 63, so it's 1 less than. So we have 7 8s here. So 7, remember what? 7. Because 63 divided by 8 is 7. The main one will be what? 7. Good. So 7, remember 7. So that's 7 now. We multiply by the base you are working on, which is base 10. 7 times 10 is 70. Plus the next digit, which is 0. It becomes 70 plus 0 is 70. 70 divided by 8. 8 times 8 is 64. So we have 8 again. 8, remember what? 70 minus 64 is 6. So 8, remember what? 6. So let's continue. 8 again. 8 divides 78. Inside 78, we have 72. So 72 already is 9 8s. So it's 9. 9 remainder 6. Is 9 remainder what? 6. Is 9 remainder what? 6. Because 9 times 8 is 72. 72 plus 6, 78. So 8 will go again. 8 divide 9 will give us 1. Remember what? 1. There is 1 8 inside 9. Remaining 1 is will be 1. So 8 divide 1 is what? 0. Remember what? 1. We read upward. So by implication, this is telling us that 5046 to base 10 will give us what? 11666 to base what? 8. Please, I want to give you a clue or an expo. When you are solving things like this, when you are moving from base 10 to base, any other base, if at the end, after solving, you get a particular answer, please take your time. If you still have time, try to move it back, just in a rough walk. Check. Move that number again back from that base to base 10 and see whether it will give you the same answer before you can confirm that it's correct. So this is what I normally do when I'm solving this in exam condition, unless there's no time to check. Once there's time, a rough walk, I'll check to be sure that if this were what we are to be in exam hall now, I'll try to move this 11666 base 8 back to base 10 and see what I will get. That's what I will do if I have time for it. All right, so this will usher us to how to moving from other bases to base 10. Moving from other bases to base 10. Moving from other bases to base what? 10. I hope this thing has not moved out of the frame. Okay, it has not. So moving from other bases to base 10. Any other base, let's assume, provided it's a whole number like this, and any other base you're moving the numbers from base 10 to, it's easy. Just keep dividing, follow the same pattern. Once you know how to do your division, keep dividing and you will get the correct answer. So I wouldn't want us to go and start moving to base 3, to base 2, to base 5. Is the same pattern. This will serve as a case study. It's the same pattern. Even if you replace this 8 by 7, that means you keep dividing by 7. Keep dividing by 7. It's the same pattern. Okay? All right. So that's why I wouldn't want us to waste time on that. What I want to do now, I want us to move to talk about how to move a number in other bases back to base 10. That's what I want us to look at now. I will use these numbers here, even though I've cleaned one, but I will use these numbers here. I will write out the answers I got in each of them and use them. We'll try to move them back and see whether what we did is correct. I would have put down the answer, what I got in that first one, but no problem. Let's work with 5. 5 is okay. So we'll move it and see what we'll get. Okay. So for number A, I'll write them out first, somewhere first. Let me write the answers out so that each one we work on, we check. This is 128. This is 27. So for A, I've cleaned A. Okay, for B, we got that 27 to base 10 is 33 to base 8. Then for C, we got that I got that 128 to base 10 is 200 to base 8. Then for D, I got that 569 to base 10 is equal to 1071 to base 8. Then for E, I got that 1239 to base 10 is equal to 2327 to base 8. Then this last one, F. Sorry, I've cleaned A. I got that 5046 to base 10 is equal to 11666 to base 8. So I'll clean this board now. We'll move this thing back to base 10 and see whether we'll get the same answer. All right, let's do that. Okay, so let's work on this one first, B. Now, before that, I will introduce how to move from other base to base 10. Remember what I explained about place values. If you understand that displace value, you are good to go. So if you want to move this number 33, this is not 338, this is 33 to base 8. Sorry, this is 33 to base 8, not 338. If you want to move 33 to base 8 to base 10, it's simple. Just expand this using the place using the expanding it in 8, counting the place value of each of these digits in 8 counting system. Simple. Remember how we expanded the other one times 10? Here, just simply do this. What this means is that this means that this 33 base 8 means that there are 3 8s. It means 3 8s. Sorry, means 2 8s. 2. See what I mean? This is ones. This first position means 1 8. And that is 8 units. This position means 2 8s. That is 8 times 8. So here we have 3 1/8. Now 3 times 1/8 as a unit. Then this second one, this 3 means 3 or 3 times 2 8s. That is 8 times 8. That is what it means. The same way we did 2 times, the first example I gave, 2 times 10 times 10 for this third value. So here is let me explain better. I think I made a mistake. Let me be writing it so that I will not make such mistake again. Here, if you have 3 3 8, see what I mean here? See what I mean? This one is units, right? Units, meaning 1. Okay, that means the 80 is not complete here. It's not 1 full 8. It's just 3 units here. So, but here means that we have 1 8, not 2 8, not 2 8. I mean 1 8. That is 8 ones. Let's assume we have 3 to base 8. Here means 8. This 3 now, this digit times a unit, just 1 unit, mean 8 to the power 0. Here, plus this one, this 3 times 1 unit of 8 to the power 1. Then plus this 3 here times 8, 2 8s, 8 times 8, which is 8 squared, plus this 3 here times 3 8s, which means 8 times 8 times 8, 8 to the power 3. That's, if you expand like that, any number you get is that the value of this number in base 10. So let's do that. I hope this explanation is clear. Let's do that. Let's do that. So let's expand this. So this becomes, this first one here is 3 times what? 1 unit, which is also taken as what? 8 raised to the power what? 0. Then plus this 3 here times 1 full 8, 1 8, 8. So this is where they got this. They tell you start here and start raising the powers. You just to express it in a way you understand. So this is, if you want to do that way, here becomes, from law of indices, 8 raised to the power 1 is that same number is 8. So that means 8 is certain as 8 raised to the power 1. Then plus 3 times any number raised to the power 0 is 1, but we are working in base 8. So here it's also 8 raised to the power 0. So that's where they got this. So for easy understanding, you multiply the base, each of the digits by the base. Then after, you start raising them from 0 up to the final digit in order of their place values. Simple. So with that now, I think we can now solve this thing. So here is, this is now 3 times 8, which is what? 24. Plus 3 times 1, which is what? 3. 24 plus 7 is what? 27 to base 3. To base 10. Is it correct? It's correct. We have moved 3 to base 8 to back to base 10, and we got the same answer. So what we solved in that first one is correct. Okay. Now let's look at C. C. We want to move 200 to base 8 back to base 10. 200 base 8. Based on their place value, the one with least place value here is 0. That this digit is 0, followed by this one, followed by this one. And they increase by power of 8. They increase by 8, sorry, by 8. Now, see what I mean? This is 0 now. This 0 now, if you want to expand this, that here becomes this 0 times 1 unit, which is 8 raised to the power what? 0. So here we have 8 to the power 0 times what? 0. Then you add it to this one. Here now, we now multiply it by, because 1 times 8, you know, here is 1. 1 times 8 is 8. So you multiply it by 0 times what? 8, which is 8 raised to the power 1. Then plus, no space. Okay, for want of space, let me do this like this. For want of space, here is what? C. 200 base 8 is equal to, for want of space. All right, so then plus these 2 now. These 2 times, you multiply this 8 here by another 8. It becomes 8 squared. Simple. So this will give us what? 8 squared is 64. 64 times 2 plus 0 times 8 plus 0 times 8 to the power 0 is 1. Here is what? 0. Here is what? 0. Because all these things is 0. Here is what? 2 times 64 is 128. So the answer is what? 128 to base 10. Is it correct? It's correct. So 200 to base 8 is what? 128. TEDx official, you're welcome. TEDx official. TEDx official, you're welcome. You're welcome. Okay, so now the next one. Please, as you join, please like the streaming, like it, share with your friends, invite them to come. Please, for our full lectures, please visit our YouTube channel. The YouTube channel name is From Eternity, the Schoolboy. Here we see the full lectures of recorded lectures of these live streams. All right, please, let's continue. That's for C. Then let's look at D. Let's see whether we got what I solved or not. Let me start from here. So no, I'll block this place. So this is what? D. We got 1071 to base 8. 1071 to base 8. Let's go. We'll start from again the least one. The least what? The place value with the least place value here is this. The digit has the least place value. This one here has the least place value because it will multiply by unit. So you multiply by the unit, which is what? Of what the unit is 1, which is known as 8 raised to power what? 0. 8 raised to power 0 times what? 1. Then you add it to the second one. Okay, so you're welcome. Sorry for the break in transmission. Sorry for that. Sorry about that. So we'll continue from where we stopped. The network is having issues here. Sorry about that, please. Okay, let me set up this thing here so that I know exactly when it happens again. Okay, I stopped somewhere here. Was trying to complete what should be here before the live stream got disconnected. I just noticed from here. That's why I set this place up so that I will monitor what is happening. Thank God I was able to see it on time. All right, so now let's continue. I say that here is 8 raised to power 3. 8 times 8 squared is 64. So 64 times 8 again. Let's go. 64 times 8. 8 times 4. 8 times 4 is 32. 32. So 2, 3. 8 times 6 is 48. 48 plus 3, 51. So 512. So here is what? 1 times 512. Bracket closes. So here 1 times 1 is 1 plus 7 times 8. 8 times 8 is 64. 7 times 8 is 56. 56 plus 0 times 64 is 0 plus 1 times 512 is 512. Okay, let's add up. If you add up, we have something like this. 512 plus 56 plus 1. 2 plus 6 is 8 plus 1 is 9. 5 plus 1 plus 5 is 6. We bring down 5. So the answer is 569 to base 10. Is it correct? Let's check. It's correct. 569 to base. I'm still having network issues here. 569 to base 10. I hope you are following. 569 to base 10. 569 to base 10. Okay. Tora, you're fantastic. You're welcome. King Erum Nosele, you're welcome. Vanessa, you're welcome for liking the live. Please, others, please like and share with your friends. Okay. All right, let's continue. So the answer is 569 to base 10. So this is correct. This is also what? Correct. So let's look at the next one. That is E. Let's check whether it's true. So for E, we want to move 2, 3, 2, 7 to base 8 to base 10. Let's see what we'll get. Let's see whether we'll get this thing. 1, 2, 3, 9 to base 10. So let's go. 2327 to base 8. Let's go. We move it. The least digit with the least place value here is 7. So that's how we multiply the unit, which is 8 raised to the power 0. So here, 8 raised to the power 0 times what? 7. You add it to the following digits, which is 8 raised to the power 1 times 2. Next one, 8 raised to the power 2 times 3. Next one, 8 raised to the power 3 times 2. 8 raised to the power 0 is 1. So 1 times 7 plus 8 raised to the power 1 is 8. 8 times 2 plus 8 raised to the power 62. 8 raised to the power 2 is 64. 64 times 3 plus 8 raised to the power 3. We establish it as 512. 512 times 2. So let's open the brackets. 7 times 1 is 7 plus 2 times 8 is 16 plus 64 times 3 is what? 64 plus 64 is 128. 128 plus 60 is 188. 188 plus 4 is 192. So this is 192 plus 512 times 2 is 1024. This is 1024. So let's add up 1024 plus 192 plus 16 plus 7. Let's go. 124 plus 100 is 1124. 1124 plus 90 is 1124 plus 90 is 1214 plus 2, 1216 plus 16, 1332 plus 7, 1000. So 1024 plus 100 is 1124 plus 90, 1214 plus 2, 1216 plus 16, 1216 plus 16, 1232 plus 7, 1239. So here is what? 1239 to base 10. Is it correct? It's correct. So E part is also correct. So let's do the last one. With this, we beat our chest that no matter how they twist question in moving from base 10 to other bases or from other bases to base 10, we can solve them. All right, let's solve the last one. Let me clean here. Let's solve the last one. Network is disturbing here. Seriously disturbing. Network is seriously disturbing. All right, let's solve the other one. The last one. After this, we end this lecture. We'll continue tomorrow. Here is, we have 11666 to base 8. So let's work on this. So we expand it. The least number here, digit here, the digit here with the least place value is this last 6. So let's go. So we have, that means that should multiply the units. 6 times 8 raised to the power 0 plus, I can start, I must start from here, but it will help me to know where this will stop. So in that case, maybe I'll come down a bit. Maybe I'll come down here. 6 times 8 raised to the power 0 plus this 6 times a to the power 1 plus 6 again times a to the power 2 plus 1 times a to the power 3, then plus 1 times a to the power 4. Wow. Plus 1 times 8 raised to the power 4. All right, let's go. This one will give us 6 times 1. This will give us 6 times 1 plus 6 times 8 plus 6 times 64 plus 1 times 512, 1 times 512 plus 1 times 512 times 8 is what? 512 times 8 is, let's go. 8 times 2 is 16. 16, carry one, put here. 8 times 1 is 8 plus 1, 9. 8 times 5 is 40. 8 times 2, 16, 1 here. 8 times 8, 8 plus 1, 9. 8 times 5 is 40. So here should be what? 4096. Here should be 4096. So let's open the brackets. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's open the brackets. I hope we are following. So let's open the bracket. If you open the bracket, we have 6 times 1 is 6. Plus 6 times 8 is 48. Plus 6 times 64. 64 times 6. Let's go. 6 times 4 is 24. 2 here. 6 times 6 is 36 plus 2. 38, 384. So 6 times 4 is 384. Plus 512 times 1 is 512. Plus 4096 times 1 is 4096. So let's add this thing up and see what we'll get. So let's go. 4096 plus 500 give us 4596. 4596 plus these two will give us 4598. 4598 plus 10 on top. 4598 plus 10, 4598. Plus 10 will give us 4608. 4608 plus 300 give us 4908. 4908, take 10 from this and add there. 4908. Okay, take 2 from here and add. Take 2 from here and add. 4908 plus 2 becomes 4910. Then remaining 82 here. 4910 plus 82. 4000, okay, from plus 80. 4990 plus 2. 4992. 4992 plus 8 on top. 4992 plus this 8. It becomes 5000. 5000 plus 40 becomes 5040 plus 6. 5046. That's the answer. So we got it. Correct. 5000 what? 46 to base 10. So we've succeeded in moving these numbers from base 8 back to base 10, and we got all of them correctly. That means that what we solved by moving them to base 8 from base 10, we are all correct. So at this juncture, we succeeded in explaining and learning how to move a number from base. First of all, we introduce the number basis from the beginning, what it means, what we mean by number basis, and examples of number basis, those that are whole number, fraction. We now went down to how to move numbers from base 10 to other bases, and how to move numbers from other bases to base 10. So that's what we succeeded in learning today. So in our next mathematics class, we'll continue from there. We look at operations in binary number. Remember, we are still treating whole numbers. We have not entered fractions. Operations, addition, subtraction, multiplication, division, and what have you. And we'll solve more problems on that. All right, please, for the full lecture, this full lecture today will be uploaded by the special grace of God before the end of today or tomorrow. Please go to our YouTube channel. The YouTube channel is Farm Eternity. The YouTube channel is Farm Eternity, the schoolboy. Go there, you will see our live recordings, full lectures, live recordings on all the live lectures we've been doing here. Go to playlist, click on the playlist. You see different subjects. Click on the subject of your interest. If what you want to study is mathematics, just go to mathematics and click on mathematics. You see different topics on mathematics. You learn, you watch, share with your friends. If you have any question, feel free to ask. So we want to go on a break now. 8 p.m. We'll come back here again by 8 p.m. today for another lecture. 8 p.m. today we'll come back for another lecture on pharmacology. Please inform others. If you know your friends that are offering pharmacology, please tell them that 8 p.m. they should come back to this Farm Eternity the Schoolboy on TikTok for pharmacology classes. Please, God will bless you as you do so. Please share these lectures, like and comment, subscribe, follow us on TikTok for more. God bless you. See you by 8 p.m. Bye.